Hey y'all, it's me, Miss B. Today we are talking about adding and subtracting rational expressions. So one thing we need to keep in mind when we're doing addition and subtraction of fractions is we need a common denominator. Okay, so here you can see that we have a common denominator of c on both of those. So simple enough, we just add them together, a plus b over c. Same thing with subtraction, we have a common denominator, so we're able to do our subtraction just straight across. Okay, so go ahead and answer number 1 and number 2 and number 3 on your own. All right, these should have been pretty easy. For this first one here, you should have said 7 plus 8 is 15, and our denominator is just 16. Next up, with number 2, we've got 5 ninths minus 1/9, which is 4 ninths. And then for number 3, x minus 5 is our denominator. It does not change. And so for our numerator, we have 6 plus x plus 2. We do want to simplify that to 8 plus x over x minus 5. So we are going to start simplifying these down. All right, 4 and 5 are also really easy, but I'm just going to do these ones for us. So notice that we have subtraction. When we have subtraction, we need to make sure that we distribute the negative through. So what this is x squared plus 3x minus 2 over x plus 5 times x minus 2 plus, because this is changing it to a negative, positive 4x plus 12. So we are switching our sign there. We have the same denominator. So what we did was we distributed this through, making this a positive. So we multiplied. This is kind of the same thing as plus a negative 1, which is why we were able to do that. So we add straight across, we get x squared plus 7x plus 10 over x plus 5 times x minus 2. A lot of people would be tempted to stop here, but don't stop. This is factorable, so we've got, we are going to do PSN. So our product is 10, our sum is 7, so our numbers are 2 and 5. So we're going to go ahead and factor that. So we have x plus 5 times x plus 2 over x plus 5 times x minus 2. Oh, I wrote that wrong. X minus 2. So these cancel, the others do not, and so we are left with x plus 2 over x minus 2. You can drop those parentheses if you want. All right, so there is our final answer. All right, go ahead and simplify the next one on your own. All right, what you should have put for that one is, let's go ahead and factor these first. Sorry, we don't want to factor these first. We want to simplify first. So we're going to do, this is minus 1. So we're going to distribute this to all of these. So we have x squared minus 2x plus 3 over x squared plus 7x plus 12 plus negative x squared plus 4x plus 5 over x squared plus 7x plus 12. Add straight across, we get x squared minus x squared is 0 plus a positive 2x plus 8. You can just ignore that 0. You don't have to write it if you do not want to. And that is over x squared plus 7x plus 12. We want to factor, so the numerator we're factoring by pulling out the GCF, the denominator we're factoring by PSN. So the top we do 2 times x plus 4. And the bottom we've got two numbers, 3 and 4, multiply to be 12, add to be 7, so we get x plus 4 and x plus 3. These cancel, and so we are left with 2 over x plus 3. So that right there is our final answer. Ooh, like that. Okay, so sometimes we're going to have denominators that do not have, we're going to have fractions with not common denominators. So we are going to have to determine the least common denominator. All right, and then we'll rewrite the fraction with the same denominator. And the way you do that is by multiplying the numerator and the denominator by any factors to get the least common denominator. You'll add or subtract the numerators, and then when possible, you'll factor the rest of it. So to kind of simplify, basically step 1 is get the same denominator. Step 2 is add and subtract, or add/subtract. And step 3 is simplify. Okay, so first here we can see that we don't have the same denominator. I have a denominator of x and of x squared. So between x and x squared, my least common denominator is going to be the number that multiplies to be the smallest thing. So what do both x and x squared multiply to be? And what's that smallest number? So if you think about it, x squared is equal to x times x, and x is equal just to x. And so x squared is the least common denominator. Because all we have to do is take this and multiply it by x over x. And so we get 1 over x squared plus 3x over x squared. And then we just add straight across. So 1 plus 3x is 1 plus 3x over x squared. Okay, we added and subtracted. There's really nothing to simplify from there. All right, next up, got 1 over 18x to the third y plus 5 over 27x squared y to the third. So let's think of this in terms of 18. So we've got 18 x to the third y and 27 x squared y to the third. So basically the biggest y we have is going to end up being our thing. So I know I'm going to have y to the third, and I'm going to have x to the third. So then just 18 and 27 are going to be the ones. So 18 is 2 times 9. I'm just going to go ahead and write x to the third times y. And then this is 3 times 9. So I know that the 9s are in common, but the 2 and the 3 are not. So 9 times 2 times 3 is going to be the least common denominator between 18 and 27. So that is 18 times 3 would be 8 times 3 is 24, 40, 54. Oh, that would have been way easier if I had just done 9 times 6. So 54. So we have 54, x to the third, y to the third is my least common denominator. So now I have to change these to where I multiply them to get the least common denominator. So I'm going to multiply this one by what's left over. So I just need to multiply 18 by 3, y squared over 3y squared, because that's the same thing as multiplying by 1. On this side, I'm multiplying by 2x over 2x, because again, that's the same thing as 1. So we get 3y squared over 54x to the third, y to the third, plus 10x over 54x to the third, y to the third. So you'll see that we have the same common denominator here, and it's as small as it can possibly be, because if we don't get that, then we're going to have a lot more simplifying to do in the end. And all we had to do was multiply by that, by what was left over. So then we get 3y squared plus 10x over 54x to the third, y to the third. And we cannot simplify that, so this is our final answer. All right, so we've got a lot of examples here. All right, I'm gonna do 2 of them with you, and then 2 of them we'll do in class. So let's go ahead and do 9. So notice that we have x minus 3 is our denominator and x plus 5 is our denominator. Because of that, our least common denominator is just going to be x plus 5 times x minus 3, whatever that is. We'll figure it out in a minute. So we're going to multiply this one by x minus 3 and this one by x plus 5. Oh wait, I didn't do that right. I'm sorry. We're going to do this over x minus 3 over x minus 3, so we have that's equal to 1. And this one will multiply by the other one, so it's x plus 5 over x plus 5. And then multiply straight across. So we are multiplying by each opposite denominator. So we get x squared minus 3x over, again, we'll just leave this for now, x plus 5 times x minus 3. Plus 2x plus 5. Oh wait, 2x plus 10. Don't forget to distribute. Over x plus 5 times x minus 3. We have the same denominator, so I can add straight across. So we get x squared minus x plus 10 over x plus 5 times x minus 3. See if the top is factorable. X squared minus x plus 10, so I need 2 numbers that multiply to be 10 but add to be -1. The numbers do not exist, so we are going to leave it as that. If you want to, you can multiply out the denominator. So it's x squared minus plus 2x minus 15. Okay. And then last up here, we've got a problem. Let's factor first, and then we'll figure out what we have to multiply out. So I'm actually going to write this. Yeah, let's just factor first. So we have 5 over. Notice how in this I have an x and an x, so I'm going to factor out that x. All right, and then factor this next one here. So I have a 5 in common, so factor out a 5. All right, so we're pretty close. We've got x minus 5 in both of these. I'm going to multiply this one by x over x because it's what's on this side here. And then I'm going to multiply this side by 5 over 5 because it's what's here. So then I'm going to get 25 over 5x times x minus 5 minus x squared over 5x times x minus 5. Going to go ahead and combine those, so it's 25 minus x squared over 5x times x minus 5. So when I have this right here, you'll notice this is a difference of squares, so I'm going to go ahead and factor that. So this is 5 plus x times 5 minus x over 5x times x minus 5. We are really close here with this, that I can cancel them. If you think back to the last notes, if I factor out a negative from either one, it flips the thing. So this is going to be negative. If we pull out that negative, this becomes x minus 5. And then 5 plus x stays the same. And then the denominator we're going to keep the same, not factor anything out, because then it flips the other way. So then we are able to cancel these. And so we are left with negative 5 plus x over 5x. If you want, you can go ahead and write that out as negative 5 minus x over 5x. That last step there is unnecessary, but cleaner. Okay, so go ahead, take a minute and read through these common errors that people make. I'm not going to go over them with you until tomorrow, but they are mistakes that people make and commonly get wrong. I believe that's it.